Hello, and welcome to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by Professor Mary Helen Armour. We are broadcasting live from the Allan Carswell Observatory, located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time uh, at York U Observatory. We also run in concert with our online public viewing, or as we like to call it, the OPV feed, which is run by observatory staff. And tonight we have the domes open and we are going to be mixing live and archival images on the broadcast. To navigate to our live show or find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, you can send us an email at observe@yorku.ca. You can also always connect with us on Instagram at the handle Yorku Observatory, on Facebook at Allan I. Carswell Ob. All of our programs are free, but if you'd like to make a donation, and we certainly would appreciate that, please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. Our theme today is This Week We Stay in the Solar System. So how are you doing, Professor? Heat aside, how are the skies up there where you are?
It's not bad. But being a little further north of Toronto, we seem to have a lot more of the wildfire haze. So, the skies are not, they're clear, but they're not great. I'm far enough north. I'm a bit rural, so normally I can see the Milky Way on a clear summer night. That won't be happening tonight, although I can probably still see a lot of brighter objects despite the haze.
I hear you. I know and we're probably going to talk about dark skies a bit later, but where I am, I'm about halfway between Toronto and where you are, I think. And we've also got the wildfire smoke here. But without realizing it, I went for a run this morning, and this afternoon I'm definitely feeling it in my throat, the smoke, as a result of that. But I'm hoping. I'm looking out the window right now, and the sun's going down, and there's not many clouds in the sky. I might get a little bit of observing in, but it'll be visual. I mean, this is not good for photography when you've got, because everything takes on kind of an orange tinge, and that's just not really what you want in your astrophotographs. So maybe let's get into our show this evening, focusing on some space history, and we're going to stay pretty close to Earth or the solar system this week. So, Professor, over to you.
Okay, so this week in space astronomy history, I have a couple of items that relate to missions in our solar system. The first one is, of course, the Dawn mission, which on July 16th, 2011, went into orbit around Vesta. And this was quite interesting because you were in orbit now around an asteroid rather than a planet. And Vesta is fairly large. It's a few hundred kilometers across, so you can actually sort of go into a more stable orbit around it as compared to, say, some of the smaller asteroids or comets that have been visited. And Vesta is quite an interesting object, and the Dawn ended up staying there for quite some time. Um, it stayed in the area around Vesta for a couple of years, and it did quite a bit of exploration of this asteroid. And it was quite interesting because we got to realize that maybe asteroids from this are not quite so static as maybe we thought their surfaces was. There seemed to be evidence of sort of geological activity and other, surface processes that occur on the surface of this asteroid. If you look at the surface of Vesta, it does look very similar to surface of other planets. Um, it does have some fairly significant basins and some fairly high peaks, comparable even to Mars's Olympus Mons. So it is quite an interesting object that way. And they're still like analyzing the data from all this to get a good explanation of what exactly is on Vesta. But it turned out to be a much more, I guess, geologically interesting object than I think had originally been expected. Of course, the other major probe that had sort of a major flyby on July 14th, 2015 was, of course, the New Horizons Pluto flyby. New Horizons took 10 years to get out there. The cameras obviously had been on for some time before this, but at the closest approach, that's when you get the best images. So many of those images we now see of Pluto with a fair bit of detail as to the topography and sort of the surface features come from this flyby. New Horizons continued on, obviously, well after this, and eventually went on to Arrokoth. And they are potentially, because New Horizons still has some power, seeing if they could find yet another object it could fly by. So it is technically still, in some ways, an active mission. But the New Horizons flyby of Pluto was quite the event because it was the first time anything had come anywhere close to Pluto. And Pluto was kind of an oddball, as most people are probably aware. We used to consider it the ninth planet, but in the early 2000s, it was kind of booted out of the planetary club, and mostly due to orbital characteristics. But when we look at the planet, it is also significantly different in composition and structure as compared to either the inner rocky planets or the outer giant planets. It now belongs to that group that we call dwarf planets. And it does actually look in composition much closer to some of the icy moons of the giants than it does to any of the planets. So it's quite an interesting object. And this is where we got our first good look, so we could map it. We could see icy surfaces. We could see topography. We could see structures that look like glaciers and a whole lot of other interesting things that all came out of this flyby, because even something as good as the Hubble telescope could not get any kind of detail the way we saw from this flyby.
Yeah, it's interesting. They're two fascinating missions, actually. Dawn entering orbit around Vesta. Yeah, it did, but then it moved on because it had a special kind of engine called an ion engine, and it was the only the second time an ion engine had been used for interplanetary travel outside of Earth orbit. But it was the first spacecraft to orbit two uh, asteroids. Well, one asteroid, which is Vesta, and then it moved on to Ceres, which is a dwarf planet, and was the first quote unquote asteroid discovered. And New Horizons, what I always found fascinating about it was the pictures of Pluto were phenomenal. Um, but it also imaged Pluto's largest moon, Charon, and I think they discovered on the way out there, they discovered five small moons. And I think it imaged all of them. Some of them were just basically a couple of pixels wide because they're very small, but some of them it got in some detail. And then, of course, it went on. Now, sadly, New Horizons, while it's still quite capable of going to another Kuiper Belt object, its extended mission may be on the chopping block with all the NASA budget cuts coming down, but there are some efforts to preserve those missions. So, cross your fingers, cross your toes, knock on wood, whatever you need to do. Let's hope they can keep that mission going.
Yeah, I mean, the really expensive part of the mission is done. The probe is launched, the probe is out there. It's a lesser expense just to keep monitoring it than to have to launch a whole new mission in the future. Right?
Oh
So
yeah, canceling it
hopefully
would.
they manage to keep it alive. So who
Yeah,
knows?
canceling that and Juno and a couple of others would be very much penny wise, pound foolish.
Yeah.
Uh, but going back to July 14th, 1965, which is 60 years ago today, I guess. The Mariner 4 spacecraft completed the first successful flyby of Mars. Now, the Mariner program is conducted by the American Space Agency, NASA, to explore other planets. And between 1962 and late 1973, NASA's JPL, Jet Propulsion Laboratory, built 10 robotic interplanetary probes named Mariner to explore the inner solar system. They visited Venus, Mars, and Mercury for the first time. And they also returned to Venus and Mars for additional close observations. Mariners 3, 4, 6, 7, 8, and 9 were all targeting Mars. But Mariner 3 and 8 both failed, which means that Mariner 4 was the first successful flyby of the red planet. Now, it's important to understand the expectations for this mission. Before Mariner 4, it was hypothesized that Mars could be quite Earth-like. It had polar caps, which seemed to go through seasonal changes, and also through a stunning combination of misinterpreted observations, optical illusions, and groupthink on an epic scale. Credible scientists believe that Mars was covered with canals which could transport water from the poles to the rest of the surface. Sounds like science fiction to us, and in fact, much science fiction of that era was based on that. Burroughs' Presume and John Carpenter novels, Bradbury's The Martian Chronicles. Robert Heinlein wrote 2 books, Podkayne of Mars and Stranger in a Strange Land, and they were all based to a greater or lesser degree on this view of the fourth planet for the sun. And the science was sketchy due to a lack of evidence, so this view was widely shared. When Mariner 4 flew by Mars, it captured 21 images and 1 partial image. And the images covered a discontinuous swath, so they weren't all like just one clear swath of the planet, but it went from sort of 40 degrees north, so halfway between, the pole and the equator, and about 35 degrees south. And they covered about 30 degrees of longitude. And that represented about 1% of the planet's surface. The images taken during the flyby were stored on an onboard tape recorder with, yes, mechanical reels and magnetic tape, and then stored for later broadcast to Earth. But what they showed was quite unexpected. Instead of an Earth-like world, Mars far more closely resembled the Moon with numerous impact craters and a very thin atmosphere. It was clear that Mars didn't offer much hope for intelligent life, and later Mariner missions, particularly the orbiter Mariner Mine, backed up these observations. One interesting side note, the tape recorder. The one used on Mariner 4 was a spare, not originally intended for the Mariner 4 flight. It was a backup, and something went wrong with the original one, so they swapped it out. But then between the failure of Mariner 3 and the fact that the Mariner 4 recorder was a spare, and there was some error readings indicating an issue with the tape recorder, it was determined that the team would test the camera function definitively. So the way they did this, it's incredible. When they were waiting for the data to be computer processed, the team went out to an art supply store and got a pastel set to hand color, like paint by number style, the numerical printout of the raw pixels. This resulted in providing early verification of the camera function, but the hand-drawn image really is quite close to the computer processed one. So the very first picture of Mars was actually hand-drawn. I love that story.
Yeah, I mean, technology then was not what it is now. I mean, people think, oh, it only sent back 22 images, but you've got to remember, this is 1960s technology. By the standards of the time, it was phenomenal. I mean, we kind of, I guess because we're so inundated with, beautiful images from so many probes and the JSW, JWST, and now Vera Rubin, and previously Hubble, we're a little jaded to it. But when these 22 images came back and they were finally published, it was just it was phenomenal. Like these were just something that had never been seen before. So it really was quite epic at the time, right? And I think we lose some of that. And they ended up actually naming Valles Marineris after the Mariner probes that flew by the planet.
That is absolutely true, and it's a great tribute to those workhorse spacecraft. And you're right. I mean, there was a huge shift in technology over that time, and now here we're talking uh, uh, basically kilobytes of data. And now, you mentioned Vera Rubin. It's pulling in 10. It will pull in when it's in full production, 10 terabytes a night. So that's 369 orders of magnitude greater,
Oh,
and
yeah.
that's from one telescope. So we have seen an evolution in technology. But saying that, even jumping forward 30 years from 1965 to 1994, there was a big technology evolution as well. And I think you want to talk about that as well in your next point.
Yeah, so the next interesting one, and I still remember this at the time. It was quite spectacular, so I'm giving away a little bit about my age, but it was the impact of the Shoemaker-Levy comet onto Saturn. So this comet had been discovered a little over a year earlier. As is typical for comets, their name comes from their discoverer. So you were talking about Carolyn and Eugene Shoemaker and Dave Levy, who discovered it. And the funny thing is it seemed a little bit odd for a comet. Um, and the other thing they realized is that it was actually sort of bound to Jupiter rather than the sun. So it was actually going to orbit around Jupiter rather than orbit around the sun. Uh, this seemed a little odd. So the sort of this realization they came to is that this comet had been orbiting for some time, but sometime in the last few decades, it had actually been captured by Jupiter because it got a little too close. So Jupiter's gravity pulled it in. Um, and it was then they started to sort of refine the orbit, and they realized that by July 1994, it would pass so close to Jupiter that it was on a collision course. So the cool thing about this is we knew it was going to collide even prior to its happening. So they could be sort of ready and waiting with the cameras in order to photograph Jupiter. And the really important thing about this impact, I mean, the impact itself was quite spectacular, but as the fragments of the comet impacted into Jupiter, it sort of digs a hole, so to speak, into the atmosphere and allows us to get a better sense from observing the impact as to some of the structure of Jupiter's atmosphere. So lots of telescopes were trained onto it. Um, Hubble, Galileo, even Voyager 2 was turned sort of back towards to look at it. And of course, anybody with any good observing rig, I mean, certainly something like the 1 meter telescope we have here at York would have been able to observe this and been operating at the time. And so the pieces started to slam into Jupiter around just after 4 in the afternoon Eastern Daylight Time. And these things are moving quite fast. When you look at asteroid and comet impacts, you're looking generally a minimum velocity of about 60 of about um, 20 to 30 kilometers per second. This one hit Jupiter at about 60 kilometers, and that's per second. To put it in perspective, that's getting up to over 100,000 kilometers an hour. It created a massive fireball that extended sort of, a few thousand kilometers out from the surface of the atmosphere. And the impacts, because the comet had been broken up, continued over the next several days. And the really cool thing that you could see for a little bit of time after the impacts was this sort of series of dark spots in the atmosphere of Jupiter. So this wasn't the only time this had happened. In around that same time frame, about 15 years later, Another asteroid seems to have hit the planet and created sort of a large dark spot. And now we've been watching Jupiter more closely, and we've seen a number of these other events, but it's fascinating because it's not only kind of cool to see the impacts and the effects, but when we look at how the atmosphere of Jupiter is disturbed, it can actually help us learn a lot about the atmosphere as these impacts take place. Okay? So that was another quite important one at the time. And again, this was just at the time when camera technology was getting really good because we had CCDs. This is around the time they were invented, and that made a huge difference in the quality and quantity of images you could take. So there was quite a bit of observation of this, and it was so cool because they actually anticipated it, so they could see all of this happening in sort of real time as this comet impacted onto the surface. So.
It's interesting you talk about the CCD capability, because you mentioned that Galileo, which was the Jupiter orbiter, was heading to Jupiter and was able to image this, the impact. But what had happened was Galileo had a very large antenna, which was designed to transfer large quantities of data from its CCD camera back to Earth, but it didn't open properly. So one of the things was that Galileo had to, on board with its rather primitive computer systems of the day, compress the images and then send them out through what was called its X-band antenna, which is a slow data rate. Uh, but it was still able to transmit huge amounts of data. And so when they launched subsequent spacecrafts, they didn't fold up the antenna and have it cold welded as it tried to unload. The next one being Cassini, which was a spacecraft of the same vintage. But yeah, I remember this. It was really exciting. And, we've since seen other objects happen. There's actually a suspected object for Saturn right now as well. So not confirmed yet, but there may be a comet impact happening there. Um, but going back 50 years ago tomorrow, the Apollo-Soyuz test program launched. So lunar landings concluded in 1972 with Apollo 17. After that, NASA's manned program concentrated on Skylab, which was the United States' first space station. Between May 1973 and February 1974, NASA operated Skylab with three separate three-person crews, which were delivered to the station using Apollo spacecraft, Apollo command service modules. The Soviet Union operated Soyuz spacecraft, which, like Apollo, were workhorses, but they had less lift capabilities and were a lower technology base. Now, I will make an editorial comment about the Soyuz. It may not have been as sophisticated, but it first flew in the late 1960s, I think 67 or so, and they're still using it now. It's a couple of generations later, but it's still in use. It really is a workhorse. So anyway, in 1972, it was agreed there would be a joint mission to test the capability of joining, an Apollo spacecraft with a Soyuz in orbit and conducting mutual research. But there were quite a few obstacles to overcome. The craft weren't designed to dock with one another. They had totally different docking mechanisms. The atmospheres in the spacecraft uses different pressures and different gas mixtures. The Soyuz operated with an Earth-like atmosphere of nitrogen and oxygen at something close to a standard sea level pressure, whereas the Apollo operated with pure oxygen atmosphere, about 1/3 of the atmosphere. And if they mix those two, if they just docked and opened the hatches, terrible things would happen. The astronauts would get the bends, and you couldn't do it. You probably couldn't even open or keep closed the doors between the spacecraft. Uh, the crews and support teams did not speak each other's languages. And the Cold War was in full swing. This was 1972, and neither side trusted each other. So these problems were tackled. A universal docking adapter was developed. A docking module was created, which would allow the astronauts and cosmonauts to enter each other's ships. The crews then trained in both the USSR and the USA and learned each other's languages. And that legacy goes on today with the International Space Station. And similar efforts were made for some support staff cross training. As for the political problems, well, they worked it out. Uh, Descartes was a feature of both the Nixon and Ford administrations in the USA. Leonid Brezhnev in the USSR cooperated with that effort, so they made it work. So Apollo launched with a crew of three: Thomas Stafford, Vance Brand, and Deke Slayton. And that occurred on July 15th, which was 50 years ago tomorrow, and they carried the docking adapter with it. So it was kind of like the Apollo missions. The docking adapter was in a garage behind the command service module on the upper stage of the spacecraft. They got into orbit. Uh, the command module turned around, grabbed the docking adapter, pulled it out of this little garage, and then went off in search of the Soyuz. The Soyuz caught up with it, and they docked. So the Soviets launched the same day with a two-person crew of Alexei Leonov and Valery Kubasov. Docking occurred 3 days later and 2 days later, and they remained working together for nearly 2 full days, 44 hours. The Soyuz then returned to Earth after 5 days total, and the Americans stayed for another 4 days to continue the space experiments. Now, a couple of things about the crew, which is kind of interesting. I think about a month ago, we had in a one of our podcasts, and people can look it up. We talked about Deke Slayton, who was the command module pilot for the Apollo Soyuz Apollo ship. He was probably the most underestimated, hardest working man in the American space program. He was a Mercury 7 astronaut that never got to fly. He became the head of the astronaut office. He did every job in the world. He had a bad heart. Every time he got close to uh, achieving his goal of getting in space, something would happen, but he kept at it, and he eventually flew on this mission, the last Apollo mission. Alexei Leonov was the first man to walk in space. So, this was a sterling crew, and they pulled it off. And much of the technology they developed has descended into what we're now using on the International Space Station. It's not exactly the same technology, but it's kind of derivative of it.
Yeah, I mean, it was quite, if you think about what was going on in the Cold War, this was kind of a spectacular event. And it was really, I mean, this whole thing was really the start of the business of various space stations. Um, so, like you had the Americans, these guys docking. Skylab, I don't think lasted a particularly long time, but out of some of the technology from this, of course, the Russians built oh God, now all of a sudden the name brain freeze. I can't remember the name.
Mir.
Mir,
They
thank
built
you.
Mir. Yeah. So what had
Built
happened
Mir, which
was
was
that,
quite a spectacular one.
yeah. What happened was that the Russians had, I think, seven Salyut space stations, which were very small space stations. The Americans had Skylab. They had this mission. Mir used some of the descendant technology, and the space shuttle could visit it. And then that technology evolved out to what is now in the International Space Station.
Yeah,
It's quite a story.
yeah, I mean it has so many more long-term ramifications. I mean, it seems okay, well, they met in space and they shook hands and you see them floating back and forth in the tubes because there were pictures taken at the time. But it's all the backstory and how much had to be developed to make these two spacecraft compatible and how this sort of contributed to sort of later technology is quite important when you look at it. I mean, you can never look at these things just in isolation. They always have like effects downstream and improvements in technology and improvements in relationship because after this there were at least a couple of Americans who went up to the Mir space station over the years. I can't remember exactly who it was, but it sort of started that trend of some cooperation in space, which, despite
Yeah,
even the current tensions, there's still cooperation up at ISS. It sort of put aside the politics of the Earth to stick with space exploration.
yeah, absolutely. You know, like many human endeavors, particularly in science, uh, technology and science development are cumulative. And I think the history of space stations, if you think about it, sort of the lunar landing stuff is almost a dead end. Because they did it and they abandoned everything, and they still got the plans. They still could build it all again, but any new approaches are going to be totally different technology, probably. But space stations are a really good example of incremental design. It's a fascinating history. But I noticed that we're at halftime, so it's time for some reminders. You are listening to York Universe. We are broadcasting live from the Allan I. Carswell Observatory at the Keele campus of York University in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join the chat if you have questions or want to see some of our content. Now, it's not quite dark enough yet for live images, but I think we will get some in from the observatory. There's some beautiful archival images up now. Tonight, you're listening to Professor Mary Helen Armour and myself, Paul Mackin. We have been discussing some historical items, and if you're interested in the online public view, please navigate to our website and follow the links to join that fun. We do have a couple of reminders before we go to some news items for the week. As in the case most weeks, we'll be hosting an observatory tour in our main domes, where you can get up close with our 60 centimeter and 1 meter telescope this week on Wednesday, and learn about the work we do at the astronomy department at York University. Um, this is a great opportunity to come and look through, maybe see some of the telescopes in action if we've got clear skies. Tickets are free, and a link can be found at the website to get them. Of course, donations are always welcome. Now, on alternate weeks, so next Wednesday, we'll be hosting a live observing, which is weather dependent, at the Arboretum, which is above the parking garage on the fifth floor in the Arboretum parking lot on our Keele campus. And here we've got a number of different telescopes that you can look at, and we'll be looking at various different objects. It's very interactive. It's a lot of fun. And here, rather than looking at a computer screen, you get to put your head up to get to an eyepiece and look through the telescope. The tickets are available the same way for the observatory tours, and we alternate between observatory tours and star nights weekly. Again, weather permitting, over the spring and summer months. So now we're going to move on to some news items, and the solar system is basically the system of objects around the sun. So why don't we talk a bit about the sun, Mary Ellen?
Yeah. So
Can you,
yeah,
yeah.
it's like I said, I think it's like I said, over the last, I guess, year and a half, 2 years, of course, we've been dazzled by quite a number of very spectacular northern lights. You hit a peak of solar activity. Uh, as some people may be aware, or some not, the sun goes through an 11-year cycle, where you go from having a quiet magnetic activity to peaking, and then getting quieter again. When you hit that peak of magnetic activity, that's when you get more sunspots. That's when you get more flares. That's when you get more, generally, coronal mass ejections. The sun is just magnetically more active, and this is when we're much more likely to get northern lights. Now, you can get them anytime during the solar cycle, but you tend to get them much stronger and much more spectacularly at the peak. We're currently in what they call cycle 25. They started counting cycles a couple of centuries ago, so every 11 years, roughly, a new cycle starts. And sort of the question is now arising is, have we hit the peak of solar cycle 25? It was supposed to peak in July, like in this month, but some data is now suggesting that it's actually already peaked and starting to move down the curve if you sort of look at the various graphs of solar activity. So as it moves out of that peak, the number of sunspots gets lower, the amount of activity gets lower. So we may still get some good northern lights, but but it will sort of tail off compared to the activity we've had for the last year and a half. If you go on various websites, something like Space Weather, the NOAA Aurora webpage, they will sometimes talk about something called sunspot number. Now you have to be careful because sunspot number is not necessarily the number of sunspots on the sun. There's so many different ways of counting sunspots that they actually have a slightly more complex way of measuring it. So the sunspot number right now is around 100, which is still quite high, but it seems to be starting to decrease. Like we're going down in numbers. The solar activity is sort of starting to decrease. The other thing that is often looked at is how many sunspot-free days do you have where they just cannot seem to observe any sunspots on the surface of the sun. For the past couple of years, there have basically been 0 days with no sunspots. So there have been, pretty much every day there have been sunspots. But if you look at the history as you go through the cycle, if you're in a lull, you may have days or even weeks, sometimes even months where no sunspots appear. And then you will move into periods where, the number of sunspots and the number of days with them starts to increase. So there's a couple of ways in which they measure the solar cycle. So we now think we're moving past the peak, which means solar activity will be less, fewer sunspots, fewer northern lights. If you like to observe the northern lights, we'll probably still get a few more spectacular, quite visible ones over the next few months. If you're like someone like me who does geomagnetics, you're like, okay, thankfully it's moving, it's moving into quieter times, so we'll be able to do better observations again. So it all kind of depends. It also means we're less likely to get interference with satellites, telecommunication, that kind of thing, that all can be affected by, high levels of solar activity. So seems to be we're now starting into the downswing of cycle 25, probably a little bit earlier than they had predicted. Originally, they were figuring this would be sort of the peak month and then everything would tail off, but it looks like it's started to decrease already. So it's like I said, if you remember sort of over the last year, we've had some very spectacular northern lights. This will probably, over the next several months start to sort of die down. And then you'll probably get a few years where you have to actually be pretty far north to have much chance of seeing anything.
Yeah, it's interesting. I just came back from a holiday in Europe, and while I was there, I was visiting an old friend in Norway who's got a solar observatory, and so this was right at the beginning of July, and we got to look through and do some astrophotography with his setup, which is quite specialized, but in just a couple of images, you could still see a huge amount of activity, but again, he was saying the same thing, that not very long from now it's going to start to wind down. I would anyone who's looking at the OPV, I would suggest they take a look because we're now imaging what I believe is Mars. They're still trying to get a good exposure on it, but that is a live image, and it's certainly worth capturing. So moving out from this episode is about the solar system, and this story is definitely about something happening in our solar system, but it is an interstellar story. We've made the discovery of the third interstellar comet entering and crossing the solar system. It was discovered um, in early June, I think, by the NASA-funded Atlas Observatory in Chile, and it was pretty far out. It was magnitude 18, which is very faint, and it was entering the solar system at an amazing speed, 61 kilometers a second. Now, to put that in perspective, the fastest spacecraft we have ever built is going at 17 kilometers a second, so roughly a 1/4 that speed. This thing is howling, and it was located about 3.5 times the distance from the Earth to the Sun from the Sun, uh, and from the Earth, it was 3.5 times distance of the sun, and it was about 4.5 AU, astronomical units from the sun. Um, and it was given a temporary designation, but then it was submitted to the International Astronomical Union's Minor Planet Center, where they look for asteroids. And they originally suggested it would be on a highly eccentric path, which might come close to Earth's object. So they then examined it as a near Earth object, right? Because they're worried, you always got to monitor anything moving fast, coming close to the Earth. We want to, planetary survival is important. But follow-up observations from other observatories involving both professional and amateur astronomers began to reveal that the object's trajectory would not come near Earth, but instead would be on a hyperbolic interstellar trajectory. So what this means is it's coming in from outside of the solar system. It's going by the sun. The sun's gravity is changing its orbit somewhat, but it is not in orbit around the sun. So something with an eccentricity of 1 would be, in a parabolic orbit, and would be on the border between being in orbit and not being in orbit. But this has got an eccentricity of 6, which absolutely means it's interstellar. So it was also, checked at various other telescopes, including a good Canadian content plug here, the Canada-France Wide Telescope. And there it was identified to have a coma, which is evidence of it's a little gas cloud and a short tail, which indicated that it was a comet. So it was designated as an interstellar object and an interstellar comet. It's the third one discovered. Now, this thing is really moving fast. It will have its maximum velocity when it gets closest to the sun of 68 kilometers per second. And again, Voyager 1 is going at 17 kilometers a second, and that's as fast as we can get a spacecraft. It will pass closer to Mars than Earth. And when it goes by Mars, from Mars, it will have an apparent magnitude of 11. That's pretty faint. But if it does, that's bright enough that it might allow for observation from the telescopes on orbiting Mars spacecraft. Now, aside on this, we talked a bit about the Vera Rubin telescope, and you're going to hear a lot about Vera Rubin over the next few years, okay? But the Vera Rubin telescope should make identifying such objects far easier, because what it does is it takes a picture of the complete sky every 3 nights, and then does it again and again and again. And you can computer process the images and look for things that move. So we should be able to find a lot more objects like this. And current estimates that it will allow for, it's going to discover, probably a couple of million asteroids over its lifetime, but it will discover probably the estimate is 1 interstellar asteroid or comet per year once fully in service.
I mean, it's something that, now that we have better telescope power, we can actually tell that these things come from out of our own solar system. I mean, if you go back 30 or 40 years, you just wouldn't have seen these things. They are just too faint. And you may never have been able to get a good enough orbit to know that, it was coming in and leaving. I mean, a few years ago, of course, there was, oh God, I'm so bad at Umeumeu. Or I'm probably mispronouncing it horribly, which was that long cylindrical one.
That was the first one. That
Yeah,
was
that
the
was the
first
first
one.
one a few years ago that came through the solar system, and it generated a lot of interest, and the fact that it was cylindrical instead of round, I think, got a lot of people's attention. I mean, everybody was thinking spacecraft, and is this actually artificial? I mean, the speculation ran wild about it. Now things have probably died down a little, and something like Atlas 31 or 31 Atlas will be looked at more as, okay, it's another interstellar visitor. What can we find out about it? Because these are fascinating, that you can get something that actually came from outside of our solar system, and anything you can learn about its composition is great for comparing it to what we have in our own solar system. So it'll be interesting to see how much data they can actually get about this one. I mean, this is an interstellar comet. If you want to talk about solar system comets, there are a few every month that are around. Most of them are too faint to see, but this is something else that Vera Rubin could pick up, is are there more, smaller comets coming into the inner solar system that are solar system objects, that we just haven't found yet, because we find new comets all the time. Right? So the discovery isn't unusual. The unusual part of it is that we can actually establish that it came from outside of our own solar system.
Yeah, it's really remarkable. And again, something like Vera Rubin is just going to open the floodgates of data. We talked about earlier about that little trickle of data coming from Mariner, and uh, 1 billion times more coming in every day from Vera Rubin. If we The floodgates are just about to open, and they already have opened. I mean, I heard a story the other day that Kepler was a spacecraft, space telescope launched to look for exoplanets. But now variable star scientists, astronomers, are going back and looking at the same data for variable star information, because we've recorded all this data. So we've got petabytes and probably exabytes of astronomy data available. The problem is that, now processing it and identifying the information, but we're going to add more to it. But on a more modest level, Professor, can you maybe tell us a little bit about the astronomer in residence program up at Killarney Provincial Park? Because this is how people can get involved in astronomy through events like this and other things we're going to talk about in a few minutes.
Yeah, so I mean, at this time of year when the weather is good and people are more willing to be outdoors, well, it hasn't been a great summer for observing, but um, a lot of parks now have various what we call dark sky areas. Killarney Park in particular is a dark sky area. If you go up to the park, you will quickly discover outside of the main reception building, there are no electric lights in the park at all. There is no electricity at any of the campsites, so it is a very, very dark location. It's a really nice spot. And over the last 3-4 years, the York Observatory has become involved, because they managed to get donations and raise enough funds to put a relatively decent sized telescope, like amateur type telescope, in a small dome up there. And so what happens is over the summer, York sends up either some of the faculty will go up there for a week, or some of the grad students, or some other sort of astronomers from the Royal Astronomical Society Toronto branch will go up there and actually do some public outreach. We do some solar observing, we do some public outreach talks, and probably the most fun thing we do is, at least if the weather is good, we have an observing night that usually starts about 9:30, 10 o'clock when it gets dark. And especially if it is a moonless night, it is spectacular up there. It's almost overwhelming if you're not used to that kind of dark sky, because there are so many stars, it almost becomes hard to see some of the constellations you may be familiar with, because in skies that have a little more light pollution, you may still see the Big Dipper and the Summer Triangle and Orion. But when you get out there, you can see so much more. And sometimes it's almost like hard to pick out the well-known ones because there's so many additional stars. It starts to become a little overwhelming. The last couple of years I've been up there sort of uh, late July into the start of August. And of course, at this time of year, the thing that is coming up to look out for is the Perseid meteor shower. And I have been really fortunate to have some incredibly clear nights while I was up there. And the number of Perseids we saw, even though it was still fairly early, nearly 2 weeks before the peak of the shower, you'd still see a fair number of them. the peak is usually around, about the 12th or 13th of August. This year I'm up there that week, so it could be even more spectacular. But a lot of areas are now trying to have these sort of dark preserves so that people can actually go up and see the night sky. If you read the CBC, they've had an article around for the last week or so about how in many cities and stuff we are losing the night skies. And then when you throw in all these satellites, like the Starlinks and uh, the whole constellations of these things, particularly the low orbit ones, it's becoming challenging to sort of see the night sky in the way that you would see it without all these other sort of lights and objects blocking the views. So Killarney is about 4 or 5 hours from Toronto, depending on exactly where you're leaving from. But the astronomical observing up there is pretty spectacular. The geology is pretty interesting too. So it's a great place to visit if you're interested in that. And there's a lot of the provincial parks in Ontario will have sort of variations on that, or simply because they're so remote, the viewing will be quite incredible.
It's interesting. When I was younger, I used to go to a big astronomy convention every year in Springfield, Vermont, called Stellafane, and it's kind of famous in a particular subset of the astronomical community. It's uh, it's for telescope makers specifically. Now, when I was very young, I used to make my own telescopes, and we even had an acronym, an ATM, which has now become automated teller machine. But in the day before those existed, that was amateur telescope maker. But when you go to Springfield, Vermont, it's not a dark sky preserve, but just they've managed, the community has made a real effort to make sure they have got dark skies for this convention and for the Springfield Telescope Makers, which is the club that runs it. But this is actually becoming a thing because of the light pollution that we're seeing in so many communities. I mean, we've got a great telescope at York University, but when you actually look at the sky from the arboretum, there's a lot of light pollution, and it's really hard to see a lot. And you're right. People, when they go off to the country and they look at the night sky, they can actually be shocked by what they see because it's a totally different experience. So there's this effort to have these dark sky preserves and to encourage astrotourism. Now, within not terribly far from the GTA. So if you go up to Gravenhurst, there's some dark sky preserves. And there's a dark sky preserve in Gravenhurst. If you go out if you go out north of Peterborough, there's some up that way, and they're also out in a place called Offalant, out near uh, Goderich, Ontario, about an hour north of Goderich, Ontario. So within 3 hours, 2, 3 hours, there's a number of dark sky preserves. But New Brunswick has got this great idea that they're going to encourage astrotourism with this ambitious plan for the world's densest dark sky corridor. So there are many dark sky corridors. In fact, in the States, along Highway 89, they've got a whole bunch of them, and it goes like for 1,000 kilometers or something. They've just got all these different ones, but the density is quite low. They may be a couple of 100 kilometers apart or whatever. So this is within about 200 kilometers. There's going to be 6 dark sky sites along the Bay of Fundy coastline. So you can go there, you'd be able to camp or stay in a hotel or bed and breakfast. During the day, you can look at the tide come in on the Bay of Fundy, which is the biggest tide in the world. And you've got these great skies at night. This isn't just astronomy, this is astrotourism, right? The US has announced their big astrotourism project, which goes from Canada to Mexico. It's not just 1,000 kilometers, it's a couple of 1,000 kilometers. Um, uh, but this is a lot of sites in a very small area, and this is really something that we should celebrate. And I would encourage people to go to Killarney, um, to go to places like I've mentioned in Ontario. You can just look up dark sky preserves in Ontario, and you'll get a list of them. Or if you want to go down to the States, there's a bunch there too. And Quebec's got them. The Maritimes has lots. There's, and there's also just the country. Just go out to the country and look at the night sky. You don't need a telescope. Uh, Star map isn't a bad idea if you don't know the constellations, but you'll figure them out pretty quickly. Binoculars make a huge difference, but astronomy is one of the very few sciences where amateurs can make a contribution. And the way those amateurs do that, they all start the same way. They all go off and look at the dark sky at night and see how beautiful the heavens above us are. And it really can be life-changing and very exciting. And I've over my life, I've been involved in a lot of efforts with children looking at this, and children just suck this up. They're sponges. They just pull it all in, and it's really something worth doing. So it's summer. Get out there, enjoy the night sky. It's just beautiful. And I mean, Mary Helen, you're doing a whole bunch of work like that. We've got the observatory every week. It's just a wonderful way to share and interest people in science, don't you think?
Oh yeah. I mean, astronomy is one of those ones that people can kind of connect with because you can go out and look at the night sky. Um, and astronomy, I mean, it's got such a long history. I mean, we think in terms of astronomy in terms of telescopes and binoculars and all those kind of things, and yet humans have been observing the night sky literally for thousands of years. We have astronomical knowledge and we know for sure because a lot of it is actually in the written record, and a lot more in unwritten records in monuments like the Stonehenges or the Bighorn medicine wheels or various ones like that. So it's been a human activity for a very long time. We've kind of lost touch, I think, over the last century, with the invention of electric lights and artificial lighting. But astronomy's been part of sort of the human experience for a very long time, right? So not just from the science perspective, but the practical. That's how we learned to tell time. That's how we learned to navigate, was looking at the night sky. So, it's science, but it's also, I think, part of the human experience, right?
I've often think of it, it's a way for us to connect. We're creatures of the planet Earth, but we're also creatures of the universe. And of course, we come from the universe. We're all made of star stuff. Every element in our body was forged in the heart of stars. And so, we are part of this universe, and this is a real way to connect with it and to become involved. And the online tools are great. This is something you can easily learn. You just need to look up what's in the sky at night tonight, and you'll get good guides. And as I said, there's all sorts of places you can go. I live in a place with a fair bit of light pollution, but if I drive north for 30 minutes up to Lake Simcoe, the south shore of Lake Simcoe, which is still pretty close to Toronto, you get a pretty good night sky. It's not as good as a dark sky preserve, but it's very, very good. And this is just a way to connect. And like I said, the kids are off school. They don't have to go to bed early. Get them out there, get them looking at the night sky. So I guess we're at closing time. I will say that you've been listening to the York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Professor Mary Helen Armour and myself, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can also always connect with us on Instagram at the handle at YorkU Observatory, or on Facebook at Allan I Carswell Carsweb Ob. Our website is yorku.ca/science/observatory. And we have a lot of interesting content. And if you're so inclined, it's a great place to make a Canadian tax-deductible donation to our student-operated not-for-profit observatory. So thank you for tuning in this evening. We wish you clear skies and a very good night. Get out there and look. It's clear tonight.
Good night, all.